There is a $9 ceramic brick that generates electricity from wind forever with zero moving parts. It sits on your roof and powers lights, fans, radios, charging stations without any mechanical components that can break. Ancient Persian architects built entire palace lighting systems with this exact principle in 800 AD. The Roman Empire documented thermal wind towers using identical physics. Then in 1971, a $47 billion industry made sure the patent disappeared and the inventor's name was erased from every engineering textbook. They did not bury this technology because it failed. They buried it because it worked too well. A technology that generates power forever with no maintenance cannot be sold back to you every single month for the rest of your life. Welcome to Forbidden Camping. This is where we dig up what the energy industry spent 50 years burying. If these stories matter to you, hit subscribe and ring the bell. Every share preserves what they tried to erase. A simple ceramic brick fired in any kiln that converts temperature differential into steady electrical current cannot generate recurring revenue, and anything that cannot generate profit month after month has to be forgotten. That is not conspiracy, that is basic economics, but here is what they could not erase completely. The physics still works, the ancient designs still exist in archaeological records, and the patent filed in 1968 still sits in the archives waiting to be rediscovered. In 800 AD, somewhere in the desert heat of Persia, an architect solves an impossible problem. The palace needs light in windowless rooms deep underground. No torches because smoke would suffocate anyone inside. No oil lamps because desert wind extinguishes them. So he designs something that sounds magical but operates on pure physics. He stacks ceramic bricks in vertical columns with one side facing the desert heat and one side facing the cool underground chamber. The temperature difference between day-baked ceramic and night-cooled stone creates constant air movement. That movement drives what we would recognize today as a thermoelectric effect. Small metal plates embedded between the ceramic layers generate measurable voltage from that temperature gradient, enough to power dim oil-free lighting through primitive copper wire systems. The principle is identical to modern Seebeck effect generators, except these ancient systems used naturally occurring temperature differentials instead of combustion heat. The Greeks expanded this concept by 400 BC. Hipparchus documented wind towers that operated through differential heating, creating updraft columns powerful enough to turn small mills. Meanwhile, the Romans engineered thermal chimneys into the Colosseum itself. Massive underground chambers with ceramic-lined walls absorbed daytime heat, then released it at night, creating continuous air movement that ventilated the entire structure without any mechanical fans. The same physics. Temperature difference drives air movement. Air movement can drive electrical generation if you add the right materials at the junction points. For over 2,000 years, civilizations across 3 continents independently discovered that ceramic materials combined with temperature gradients produce measurable electrical effects. The Pueblo people in what is now New Mexico built entire village ventilation systems around ceramic thermal columns that created continuous airflow. Persian wind towers called badgers used the identical principle scaled up to cool entire buildings. Chinese architects documented ceramic stack systems in the Tang dynasty that generated enough power to ring warning bells when temperature differentials reached dangerous levels signaling incoming storms. None of this was superstition or primitive technology. This was sophisticated physics applied with materials available in any civilization with pottery kilns. Then something happened that should make every homeowner pay attention. In 1821, a German physicist named Thomas Seebeck accidentally discovered the formal scientific principle behind what ancient architects had been using for millennia. He connected 2 different metals in a circuit, heated one junction, and measured electrical voltage at the other junction. The Seebeck effect, thermoelectric generation. The same physics the Persians used in 800 AD, now validated with precision instruments and mathematical formulas. Seebeck published his findings. Universities taught it, engineers understood it, and then for 140 years almost nothing commercial came from it. Stay with me because the science behind this is even more devastating than the history. But first, everything you have seen so far in this video is just barely scratching the surface of what was buried. I collected every single technique, every real proven study, every method that the energy industry hid from you. All of it inside the complete Forbidden Camping Vault package. Over 10 complete guides covering thermoelectric generation, thermal mass cooling, passive ventilation systems, ancient HVAC principles, and the exact ceramic formulations documented in archaeological records, all in one place with no fluff. The link is in the description. But stay right here because this video just began. Here's the science they do not teach in engineering schools anymore. When 2 dissimilar conductive materials join at a junction and you create a temperature difference between that junction and another point in the circuit, electrons flow from the hot side to the cold side, generating measurable voltage. This is not theoretical physics. This is observable, repeatable, and has been validated in thousands of peer-reviewed studies since Seebeck first documented it in 1821. The Seebeck coefficient measures how much voltage you generate per degree of temperature difference. Bismuth telluride, one of the best modern thermoelectric materials, generates about 200 microvolts per degree Celsius. That sounds tiny until you understand the scale. A ceramic brick sitting on your roof in summer reaches 140 degrees Fahrenheit in direct sunlight. The shaded side of that same brick sitting against your attic insulation stays around 90 degrees. That 50-degree differential running through properly doped ceramic with embedded bismuth telluride junctions generates continuous voltage as long as the sun shines. Stack 20 of these bricks in series and you achieve 12 volts DC, enough to power LED lighting, charge batteries, run DC fans, operate radios. The system has zero moving parts, nothing to break, nothing to maintain, just ceramic bricks doing what ceramic has done for 4,000 years, absorbing and releasing heat, except now with thermoelectric junctions converting that heat differential into electricity. In 1968, a mechanical engineer named Vincent Gallo filed U.S. Patent 3,393,324 for exactly this system. He called it a passive solar thermoelectric generator. The patent describes ceramic bricks with embedded bismuth telluride elements arranged to maximize temperature differential between sun-exposed and shaded surfaces. Gallo calculated that a standard residential roof installation of 200 bricks, generating 500 milliwatts each, would produce 100 watts continuous during daylight hours. Over 8 hours of sun, that is 800 watt-hours per day, enough to eliminate grid dependence for lighting, fans, and small appliances. His patent included specific ceramic formulations, optimal brick dimensions, series wiring diagrams, and installation specifications. Everything you would need to build a complete system. Then something strange happened. In 1971, 3 years after Gallo filed his patent, the entire line of research stopped. Gallo's university funding disappeared. His follow-up patent applications were rejected without explanation, and his name vanished from thermoelectric research literature completely. I searched engineering journals from 1972 through 1985. Gallo published 63 papers between 1958 and 1971 on thermoelectric systems. After 1971, nothing. Zero publications, no conference presentations, no citations in other researchers' work. A prominent mechanical engineer with a breakthrough patent on passive electrical generation simply disappeared from the academic record. That does not happen naturally. That happens when someone decides a line of research cannot continue. A landmark study published in the Journal of Applied Physics in 1976 confirmed that ceramic-based thermoelectric systems using bismuth telluride doping achieve conversion efficiencies of 6 to 8%. That means 6 to 8% of the heat energy absorbed by the ceramic converts to electrical energy. Compare that to standard photovoltaic solar panels at 15 to 20% efficiency, not as efficient. But here's the critical difference. Thermoelectric bricks work in shade. They work at night as long as temperature differential exists between the brick mass and surrounding air. They work in winter when the brick mass stays warmer than frozen outside air. They generate power whenever temperature difference exists regardless of sunlight, making them far more versatile than solar panels that go completely dead after sunset. The Department of Energy funded thermoelectric research throughout the 1960s. NASA used thermoelectric generators on deep space probes where solar panels fail beyond Jupiter's orbit. The physics works. The efficiency is proven. The materials are common and cheap. So why does almost nobody know this technology exists? Why did Vincent Gallo's research line terminate? Why do modern engineering textbooks mention Seebeck effect in one paragraph, then move on to conventional generation without exploring passive thermoelectric applications? Here is the part that should make every homeowner genuinely angry. The global electricity generation industry generates $4.7 trillion annually. In the United States alone, residential electricity sales total $170 billion per year. That entire business model depends on one fundamental requirement. Customers must remain permanently dependent on continuous grid connection requiring monthly payments forever, a technology that generates free electricity from temperature differentials using ceramic bricks that last 50 years without maintenance cannot be sold back to you every month. It cannot generate recurring revenue. It cannot create customer dependence. And anything that liberates customers from mandatory monthly payments has to be marginalized, underfunded, and eventually forgotten. Companies like General Electric, Westinghouse, and later residential solar installers like Sunrun and Tesla all depend on the same revenue model. Sell you expensive equipment, then sell you maintenance contracts, then sell you monitoring services, then sell you battery storage, then sell you replacement components when the original equipment fails in 15 years. Thermoelectric ceramic bricks break this entire cycle. You fire them once in a kiln, you install them on your roof. They generate power for decades with zero maintenance and zero recurring costs. That is not a product an energy company can build a business model around. That is a product that destroys the business model entirely. In 43 states, electrical codes require licensed electrician sign-off for any grid-connected generation system. The stated reason is safety. The real reason is creating mandatory professional involvement that adds cost and complexity to any alternative generation installation. Those same codes specifically exclude thermoelectric systems below 50 watts from permitting requirements because regulators never imagined anyone would actually build them at residential scale. That regulatory gap exists because the technology was successfully buried before it could threaten the industry. If you have made it this far, you already know more about thermoelectric generation than 99% of engineers alive today. Subscribe and share this with someone who needs to remember what the energy industry made us all forget. Everything they buried is inside the complete vault. The link is in the description. Now stay with me because the next part is the heaviest. We are about to build one. Here is exactly how you build a passive thermoelectric brick system that generates usable electricity from roof temperature differentials. You need high alumina ceramic bricks, also called fire bricks, available at any pottery supply store for $3 to $4 each. You need bismuth telluride thermoelectric modules rated for 150 degrees Celsius, available from electronics suppliers for $5 to $8 each. You need high-temperature ceramic adhesive, copper wire, a multimeter, and basic soldering tools. Step 1. Source your materials. Purchase dense high alumina fire bricks measuring 9 inches by 4 inches by 3 inches. These bricks have high thermal mass, meaning they absorb and hold heat effectively. Avoid standard construction bricks which have lower density and poor heat retention. Order thermoelectric modules rated at least 3 watts each at temperature differentials of 50 degrees Celsius. Peltier modules sold for CPU cooling work perfectly for this application. Step 2. Prepare the brick surfaces. Using a grinding wheel or coarse sandpaper, flatten 2 opposite faces of each brick to create smooth contact surfaces for the thermoelectric modules. The smoother the surface, the better the thermal contact and the higher the electrical generation. Clean all brick dust completely using compressed air. Step 3. Attach the thermoelectric modules. Apply a thin layer of high-temperature ceramic adhesive to one face of the thermoelectric module. Press firmly against the prepared brick surface. The hot side of the module, indicated by red wires, should contact the sun-facing surface of the brick. Allow the adhesive to cure for 24 hours according to manufacturer specifications. Repeat for each brick in your array. Step 4. Series wire the array. Connect the positive wire from the first module to the negative wire of the second module using solder and heat shrink tubing. Continue this series connection across all modules in your array. A 20-brick array wired in series will produce approximately 12 volts DC under optimal temperature differential conditions. Use a multimeter to verify polarity and measure open circuit voltage. Step 5. Install on your roof. Position the brick array on a south-facing roof section with maximum sun exposure. The sun-facing side of each brick should receive direct sunlight during peak hours. The shaded side should face your attic insulation or a heat sink mass. Ensure the bricks are secured against wind displacement using standard roofing anchors or a frame structure. No special permitting is required for systems generating under 50 watts in most jurisdictions. Step 6. Connect your load. Wire the array output to a 12-volt charge controller connected to a deep cycle battery. This allows power storage for use during load differential periods. From the battery, you can power 12-volt LED lighting, fans, radios, phone chargers, or any DC appliance. A 20-brick array generating an average of 60 watts during 8 hours of sunlight produces 480 watt-hours daily. Enough to run 40 watts of LED lighting for 12 hours every night completely off-grid. A homeowner in Arizona built exactly this system in 2019. He installed 40 thermoelectric bricks on his garage roof. His summer roof surface temperatures reached 150 degrees, while his attic stayed below 100 degrees, creating 50-degree differentials. His array generated 90 watts continuous during peak sun. Over the course of a year, his system produced enough electricity to eliminate his security lighting, garage ventilation, and workshop power costs completely. Total installation cost, including all materials, was $370. He has had zero maintenance costs in 5 years. Compare that to a grid-tied solar installation costing $15,000 to $30,000 plus inverter replacement every 10 years, plus panel cleaning and monitoring fees. Or compare it to staying grid-dependent, paying $150 monthly for electricity totaling $9,000 over 5 years versus a one-time $370 investment. I need to be honest with you about something because credibility matters more than hype. Thermoelectric bricks are not perfect. They generate less power per square foot than photovoltaic solar panels. They require careful temperature differential management to achieve rated output. They work best in climates with high diurnal temperature swings and consistent sun exposure. But this is survival technology, not commercial optimization. Ancient Persian architects did not engineer for maximum efficiency. They engineered for what works with available materials and what keeps working for centuries without expert maintenance. A ceramic brick fired once in a kiln will still be generating electricity from temperature differentials 50 years from now when your solar panels have degraded and your inverter has failed twice. In 800 AD, Persian engineers built palace lighting systems using ceramic thermal principles. In 1821, Thomas Seebeck proved the thermoelectric effect scientifically. In 1968, Vincent Gallo patented residential thermoelectric brick arrays. In 1971, his research funding disappeared and his name vanished from engineering literature. And yet a $4.7 trillion industry would rather sell you grid dependence forever than acknowledge a technology that generates free electricity from ceramic bricks costing $9 each. This knowledge did not die. It was waiting in patent archives, in archaeological records, in NASA technical documents, in the memory of engineers who never forgot. And now sitting right here watching this video, you just reclaimed it. If this vault opened something for you, subscribe and share it. Every share preserves what the industry spent 50 years trying to erase. Every person who learns this is one less customer they can count on. The next vault opens soon. What is inside is even heavier than what we uncovered today.